Good afternoon, everyone. My name is Alyssa Sinaway. I'm an architectural specialist here at ARDEX. I just wanted to take a minute to say thank you for joining us for yet another Learn from Home webinar. In an effort to stay connected during this time of social distancing, we will host a webinar every Thursday at 2 p.m. Eastern Time. Today's presentation is AIA certified and does count for health, safety, wellness credits, although you don't have to be an AIA member to participate. The certificates for today's webinar will be distributed via email either tomorrow or early next week. If you provided an AIA number during registration, we will report the credits on your behalf. We recently added more of these Thursday webinars to our schedule. Next week, we will once again feature our course on polished concrete. We're bringing this course back due to popular demand. So join us to learn about one of the fastest growing flooring finishes. Please reach out to me directly if you need a registration for this course. I would be happy to help. In today's presentation, we will be discussing proper substrate preparation. We will discuss preparing a variety of substrates for floor covering, talk about self-leveling and patching materials, address some of the challenges you may face in preparing substrates, as well as discuss solutions to ensure a successful installation. I'm going to turn it over to our presenter, our Director of Technical Services, Mr. Seth Pavarnik. Seth has been with ARDEX for almost 30 years and has worked with many industry associations and standards organizations. We will host a Q&A portion at the end of the presentation, so feel free to submit your questions in real time. So Seth, go ahead and take it away.
Thank you, Alyssa. Greatly appreciated. And I want to say thanks to everyone who has joined us this afternoon. We appreciate you taking a little time out of your schedule to spend some time with us. As Alyssa, we're going to spend some time here talking about proper prep. Proper prep is critical to the installation of any material going onto a substrate for its success. We're going to talk about proper prep of surfaces to receive patching and leveling products. So the bottom line here with proper prep, it's really not a one-size-fits-all philosophy. You know, the bottom line here is you're going to look at any given substrate and make the proper prep, you know, for that given substrate. Okay, in doing so, you know, making the proper prep, you know, making the proper preparation to that substrate, you know, the installation is going to perform for a long period of time. It's certainly going to cost less because we have no costly callbacks. In this presentation, we're going to spend some time on concrete. We'll look at concrete treatments such as curing and sealing compounds, the contaminants that we see out there in the industry. We'll look at the different methods of mechanical preparation, shot blasting, scarifying, grinding, those types of mechanical prep options. Certainly all concrete has joints in it, and you know, one thing we can confirm, you know, concrete cracks, we know that, so we'll spend some time on joints and cracks and how to address them. And then we'll get into the different other types of substrates, whether it's, you know, ceramic tile, porcelain tile, maybe wooden subfloors, epoxy coatings, terrazzo, and things like that. So, concrete treatments. When we pour concrete, you know, it comes out of the chute, or in this case is getting pumped, as you see. It's got to be screeded, floated, finished, and ultimately we have to cure that concrete. Okay, if we don't properly cure the concrete, you know, then we don't ever achieve, the concrete never achieves the strength properties that it was designed to achieve. Okay, so in essence, we'll talk about curing and sealing compounds that are used on concrete, but we'll also get into burnished concrete, chemical hardeners like the sodium, potassium, and lithium silicate materials, and also kind of look at moist curing, waterproof paper, polyethylene sheets as methods of curing concrete. The most common method is a topically applied curing compound, you know, referenced as a cure and seal type material. And that's basically once the concrete has been screeded, floated, or finished, you know, this liquid curing compound is applied to the surface, and it will seal that surface so that the moisture that's in the concrete does not leave too quickly. Another option here is, putting a waterproof paper or a plastic down, polyethylene, as you see in the picture, and basically keeping it covered for 7 days. That's kind of an industry standard. If you cover concrete and cure it properly for 7 days, then it'll achieve the strength properties that it was designed. Maybe you remember back as a kid when they were pouring concrete, maybe they threw burlap on it and told your dad to keep it wet for a week, or maybe they threw straw all over it and told your dad to keep it wet for a week. Those are some conventional methods of curing concrete. Obviously not done present day, because the concrete that's poured commercially, as well as residentially, they want to be back on that the following day. So very commonly a liquid curing compounds apply. So there's different types of curing compounds out there. Some are bad, and some may be okay for the installation or patching or leveling products. So the first one is what we call wax emulsion, and you can see this in the data sheet as well as the SDS. And the wax emulsions are difficult ones. They're dangerous ones. Nothing wants to stick to a wax. And the bottom line, when a wax emulsion curing compound is used, that's got to be mechanically removed prior to putting a patch or leveling compound on that surface. The second category is what's referenced as a clear hydrocarbon resin. These materials you'll see in the data sheet are labeled as dissipating curing compounds. And the thought behind this is, okay, hey, if it dissipates, that's a good thing, because they dissipate with ultraviolet light, they dissipate with foot traffic. So most people are thinking, all right, if it's a dissipating curing compound, the sun makes it dissipate, foot traffic, construction traffic makes it dissipate, it's gone. That may be the case in the middle of the slab where the sun's hitting it and where everybody's walking, but over next to the wall where the sun isn't hitting it, nobody's walking, you still may have a curing compound there. So the bottom line with these dissipating curing compounds, they're actually the most dangerous ones out there from a bonding standpoint, because you don't know if they're there, if they're not there, due to traffic, due to ultraviolet light, things like that. So with regard to these clear hydrocarbon resin dissipating curing compounds, we always say to mechanically remove those down to clean concrete. Now, there are other types, non-dissipating. These are waterborne acrylic materials. Sometimes they're a solvent-borne acrylic, basically an acrylic type sealer material, water being the carrier, solvent being the carrier. And when that curing compound dries, you have an acrylic film there, okay? The typical primers that are used for self-leveling materials, they're acrylic products. These self-leveling products, the patching products, they like to stick to acrylics in general. So there's a chance that the patching and leveling materials may be okay to adhere to an acrylic curing compound. But a couple of things. Number one, we got to make sure we know exactly what was used, and we have the data sheet and confirmation that specific product is used. If we don't know, then mechanically just take it out of the equation, get down to clean concrete. If we know what it is, we know that it's an acrylic, a waterborne or a solvent-borne, the next thing we'd want to do is, get with the manufacturer, see if that's a possibility. And then if it is a possibility, we'd want to test for absorbency, see if we're getting any water absorption into that concrete, or if we're not getting any water absorption into the surface of concrete due to the curing compound, and you would prime as the manufacturer would see fit. But the bottom line is, in that situation, we got to be 100% sure, and we'd also want to do site test areas, because I can tell you this, whether it's ARDEX or any other manufacturer, we're not back in the lab testing products with curing compounds out there to see what's compatible and what isn't. So you always have the option to mechanically remove it. Here's a picture of a concrete slab, and I can tell you that it has a curing compound on it, but I'm showing you this because I want you to kind of get a mental image of this. We're going to kind of circle back to this in a future slide. You can see that the surface is very smooth, it's been power troweled, and you can also see that it has a degree of reflectivity. Okay, so just trust me that there's an acrylic curing compound there. Okay, the bottom line in this situation, as I said a few minutes ago, remove superficial contamination, evaluate for absorbency, and then with the manufacturer, agree on the appropriate primer as necessary, and test areas as always. All right, so here's another new concrete slab. Okay, is this a cure and seal? Is this a a high gloss sealer? Is this polished concrete? Not as easy just to tell by looking here. I want you to keep this mental image here as well. If we go back to the previous one, we have a degree of reflectivity here. We got a little bit more of a reflectivity here. Is this a high gloss sealer? Not for certain. But if it is a high gloss sealer, an acrylic sealer, we'd want to confirm what was used, get with the manufacturer to confirm suitability. They may have a primer that adheres to that, and we do test areas and evaluate the test area. Okay. This is burnished concrete, and again, I'll tell you that it is because I know that that's what this is a picture of. So, no sealer, no curing compound. This has just been mechanically sealed with a trowel machine, and then covered. Could be covered with a waterproof paper or polyethylene sheet. But I want you to, take a mental note of this picture again. You can again see a little bit of reflectivity here in that picture. So it is reflecting light, even though there's no sealer there, there's no cure and seal there. It's mechanically sealed, and that sealed dense concrete is providing some reflectivity. Okay, burnished concrete, no curing compounds used. Again, superficial contaminations removed. Evaluate the surface for porosity. Most likely, you're not going to see water penetrate too well. Use the appropriate primer. Test areas are always a good idea. All right, so I showed you all those pictures, and I asked you to take a mental note of those pictures because I want to get into how we do an evaluation here. And I wanted you to look at those pictures because I wanted to prove a point here. We can't just tell by looking at concrete whether it's been sealed with a curing compound, sealed with an acrylic sealer, burnished, and cover cured, because they all had a degree of absorbency. Okay, so you can't just tell by looking. Okay, we could pour water on it and do an evaluation, but I can tell you that, cure and sealed concrete, concrete with a sealer on it, or polished, concrete that's burnished, they all don't absorb water too well. Okay, so we can do a little bit different evaluation here. One thing I'm going to make comment first, and we'll need to update the slide, but one of the things you can do with the utility knife is kind of scratch at the surface of the concrete. If it's just burnished concrete with nothing on it, when you scratch at it, you're going to make gray dust. Okay. If there's any type of clear sealer on there, whether it's a cure and seal, an acrylic, epoxy, a urethane, whatever the case, if you have a clear coating on that, when you scratch at it, that clear coating is actually going to turn a little bit white, and you'll create white fragments there. So that's a quick way to see whether there's a sealer or curing compound on that surface. Is the dust that I'm creating by scratching it gray in color, or is it white in color? Okay. The other thing you can do is do a pH test in accordance with ASTM F710. Okay. If we do a pH test on regular concrete, we're going to see a pH of 9, 10, because that's the common pH of concrete that has been poured, allowed to cure and dry as that surface carbonates a little bit. We get a pH around a 9 or a 10. If you have a sealer of any sort on there, whether it's a cure and seal, whether it's a acrylic or an epoxy or urethane, and you do a pH test on that surface, you're most likely going to get a neutral reading because the cure and seal, the sealer, whatever's there has a neutral reading. And if you get that neutral reading, that's telling you that there's something on the surface of that concrete. Okay, let's talk about the densifiers out there. These chemical hardeners, these sodium materials, potassium materials, lithium materials, they've been around for a lot of years, 100 years, and I mean literally 100 years. The original types of sodium silicates have been around something like 100 years. So they've been densifying concrete for a long period of time. And these materials soak in and react with the free lime in the concrete, and they create more concrete binder, the calcium silicate hydrate, and it densifies the concrete. It basically can make it non-absorbent. Okay, so if these chemical hardeners, these densifiers, are applied in accordance with manufacturer's recommendations, they're properly neutralized and properly rinsed, and that concrete's allowed to dry, there won't be any physical bond breaker on the surface of the concrete. Now, the concrete's going to be a little bit different. It's going to be densified. It's going to be, if everything was done correctly, it should create a non-porous type surface. Any water on the surface is not going to absorb into that concrete like it normally would due to the chemical reaction of the silicate. Okay, so certainly water absorbency tests would have to be done. The silicate would need to be installed in accordance with manufacturer's recommendations to include proper neutralization, rinsing, and drying. And then with manufacturer's recommendations, you use the appropriate primer prior to patching and leveling. Test areas are always good as well. Parting or release agents. Okay, the most common application of a parting or release agent would be tilt wall construction. And that's when you pour a concrete slab, allow it to set and develop strength, you spray a parting or release agent all over that surface so that you can pour another concrete slab over top of it so that that second concrete slab won't bond to the first one poured, so that when that second slab cures and develops strength, they will use a crane and tilt that up into place, and it becomes a wall. So anytime there's a tilt wall project, the surface of the concrete is going to have some sort of parting or release agent on the surface, and that's so the two concrete slabs don't stick together. The problem is that parting or release agent is not going to allow anything else to adhere to that surface. Now, fortunately, with tilt wall construction, those are typically warehouse floors that commonly are just left as bare concrete, so not an issue. But if you're putting any type of coating or sealer or patching or leveling product, then certainly those parting release agents need to be mechanically removed. Some other common surface contaminants that you see out there on job sites, certainly drywall mud, the guys that are mudding walls and ceilings, prior to painting. Sometimes you swear these guys are having fights. In most cases, I kind of feel like these guys are getting paid by the bucket. They tend to have more on the floor, I swear, than you got on the walls or the ceiling. But if we have any drywallers on site, no offense, just kind of joking around here. Bottom line is the drywall mud is susceptible to water. It doesn't have real good integrity, so that needs to be removed off the concrete mechanically prior to installing, patching or leveling products. In joking with the drywallers, I might as well joke with the painters as well. These guys that spray the walls with their airless sprayers, it seems like too often they come down off the wall and go about 12 to 18 inches on the floor. Not sure of that or why. You typically got base going up, so you could probably just stop right at the corner. But anyhow, if there's if there's paint overspray on the floor, it's a bond breaker potentially. So we always say to mechanically remove that. Oil and grease, nothing sticks to oil and grease. Okay, mechanically removed, and I think we'll have some pictures on these items as well. Asphalt and tar, whether it's regular old asphalt pavement or maybe some sort of asphaltic roof or tar membrane as part of a roof. Can't install products over those materials due to the asphaltic nature or the tar-like nature. Could cause bond issues there. So mechanical removal is key. Okay, flooring adhesives. So we did talk about asphaltic materials needing to be removed. And that was more like asphalt pavement, so if they go into a mall parking lot where you got asphalt and, they basically dig out to pour their footers and 4 walls and a roof are installed and you still got the asphalt pavement there. certainly that's not suitable for patching and leveling products. Asphaltic adhesives, a little bit different story, and we will spend some time on asphaltic adhesives. But adhesives in general, okay, couple of things to keep in mind when using patching or leveling products over adhesives. So number one, the adhesive should be on a concrete substrate, okay. Adhesives adhere well to concrete, okay. The second thing is we want to make sure that the adhesive is not water soluble. Just about all your adhesives are made with water present day, but that doesn't mean that they're water soluble. Okay, Cutback, the black asphaltic adhesive, there are some waterborne, black asphaltic adhesives out there, but the traditional Cutback, and it's still made and used today, it's a solvent material. And it got its name Cutback is years ago, they used to cut that with, gasoline, to make an adhesive out of it. Use a solvent to cut it and to cut that asphaltic material, and that's how it got its name Cutback. So adhesive on concrete, got to make sure it's not water soluble. The easiest thing to do here is pour water on it. Get some warm tap water. We'll kind of go through this in a future slide, but get some warm tap water on it. Let it sit there for 15 or 20 minutes. Most likely, you're going to see that water remain clear in color. But if you do see the water going milky or cloudy in color, you feel the adhesive kind of becoming slimy, then water's dissolving it. And if that's the case, it's a water-soluble glue. We don't want to be using any product over that glue that has water in it. All your patch and leveling products have water in it. If you use that over the glue, the risk is the water in the products dissolve the adhesive, and then the whole system fails. Okay. So provided the adhesive is on concrete, provided the adhesive is not water soluble, we recommend to scrape it down to a thin, well-bonded residue. This has nothing to do with bond, okay? These patching and leveling products, doesn't matter what manufacturer it is, they will stick to adhesive that still has, the notched trowel marks in it from when it was originally installed. It's a performance issue. If you have thick adhesive, foot traffic over top of that installation could allow that adhesive to move, and then the adhesive fails. And we've seen it time and time again. You have a disbonded patch leveling product, you look at the underside, and there's adhesive stuck to the underside. You look at the concrete, and you still have adhesive on the concrete. The adhesive failed. So it's critical to scrape it down to a thin, well-bonded residue. They use tile stripping machines. They use the scrape away attachments on the bottom of the floor sanding machines. They even have ride-on machines that can scrape off flooring, and in the process scrape down the adhesive. We do caution on adhesives that contain asbestos, and we follow the Resilient Floor Covering Institute's recommendations for working with asbestos adhesives. So number one, you got to follow and comply with state and local laws for containment, disposal, working with it. And in reference to the Resilient Floor Covering Institute's recommendations, we follow their guidelines in using warm soapy water in wet scraping so that you're not creating dust, you're not allowing the asbestos fibers to become friable. The warm soapy water keeps dust down and keeps the asbestos fibers from becoming harmful in the air. Here's a picture of Cutback adhesive after some VCT was removed. You can still see the thick buildup of adhesive from originally combing that out. Bottom line is you want to scrape it down to a thin residue. And yes, there's some dust footprints in this picture that would need to be, got to remove the dust, but nonetheless, adhesive has to be scraped down to a thin, well-bonded residue, like a stain on the floor. Okay. So, we kind of went over this briefly, but I'll go through in here. When you have an adhesive on the floor, take your utility knife and create a crosshatch pattern. And the bottom line here is you're trying to evaluate the glue to make sure it's well bonded, to make sure it's not flaking or brittle. If the glue is flaking, it's brittle, it's coming off the floor, then don't put anything over top of it. If the glue fails, then the whole system fails. So the adhesive has to have integrity. It has to be well bonded to the concrete. So again, get some, if it doesn't flake off, you got good integrity, it's well bonded, get some warm tap water and put it on the adhesive for about 20 minutes. Rub it with your finger, if it feels soapy or slimy, then it's dissolving the glue. If the water's turning milky or cloudy in color, then, we're dissolving the glue, okay? A majority, just about all of your adhesives that are made present day are made with water, but when they dry, they're not water soluble. Typically, you pour water on it, warm water like this, you rub it with your finger, and the adhesive feels squeaky clean. The water is clear in color, okay? Simple test, when you go onto a project, you're walking a renovation, just get some warm tap water and evaluate the glue. Very simple. Key thing here is do not use adhesive removers or solvents to remove flooring adhesives, okay? The adhesive manufacturers don't recommend it. The flooring manufacturers don't recommend it. Patch and leveling manufacturers don't recommend it. ASTM F710, which is the guideline for the installation of resilient floor covering, in that industry standard, they detail, not to use solvents or adhesive removers. And if one is used, it's got to be removed. All concrete contaminated with that solvent or adhesive remover needs to be removed, okay? The bottom line with solvents, and here's the difficult thing. The adhesive remover, the solvent, it doesn't know the difference between the existing adhesive and the new adhesive that's going to be installed. So it does a great job dissolving the glue on the floor. You end up removing 95% of it. And what's left is a broken down residue of glue and solvent that's left in the pores of the concrete that can migrate into the pores and then eventually come back out. It can affect your new adhesive, it can affect your patch or leveling product. Things start to fail, okay? Bottom line, if a solvent or adhesive remover was used, it's very common that the recommendation is to remove all concrete contaminated with the solvent or the adhesive remover, okay? One more thing, ASTM F710, I have this in here. This is the industry standard for preparing concrete floors to receive resilient flooring. And in this standard, it details all these different contaminants that we've been talking about. It details removing them from concrete to get to the clean, sound, solid surface. So, the installers have the adhesive manufacturers, the flooring manufacturers, the patch and leveling manufacturers, and they also have an industry standard here that they can use to show that they're doing things in accordance with manufacturers and industry recommendations. So that is an excellent document for any installer to have. Okay, proper prep for concrete. We've talked about all these different contaminants. Let's take a look at how we can remove them. Okay, many different methods here: shot blasting, grinding, scarifying, scabbling, bush hammering, water or sand blasting. Okay, all mechanical methods, all suitable. Okay, we're going to kind of focus on the common ones: shot blasting and grinding. We'll touch on scarifying. Okay, shot blasting. This is a self-contained machine, different sizes, but there's a wheel inside that machine that spins at a very high velocity. There's still shot that is thrown to the concrete at a very high velocity. It works on impact resistance. The shot hits the concrete and breaks up the surface of the concrete along with contamination. There's a vac system on the shot blaster that's equipped with a HEPA filter system. The debris is very light and gets vacuumed off. The steel shot is very heavy and it gets recycled inside that contained shot blasting equipment. So it's just a repetitive motion of the steel shot getting thrown at the floor at a very high velocity. leaves with a very clean, very open surface. Okay. Sometimes one pass isn't enough though. Might take repetitive passes to remove all the contamination. Okay, here's a picture of concrete that's been blasted. You can see in the forefront of the picture areas that haven't been blasted. Obviously, center to the top, you can see where the blaster is hit. It's very clean, it's very open, it's very porous. It's easy to see where the machine hasn't hit yet. Grinding is another method. You got these planetary grinders out there that are used for polishing concrete with different diamonds, more aggressive diamonds. They can prepare the surface of the concrete. Typically, you got a big head with a few smaller heads, maybe 3 smaller heads that are spinning in a different direction. And you got diamond blades on the underside that are mechanically removing the surface of the concrete, thus removing contaminants. Here's a picture of a surface that has been prepared via grinding. You can see the different swirls in the surface of the concrete. Scarifying is another method of prep, not so commonly used. Typically, it's just an outside, even though they do have electric scarifiers. You see this one's obviously gas run, so you're not going to operate a gas a machine with an interior of a building. Scarification consists of star-like washers, and maybe you have about 30 or 40 of these star-like washers that are on an axle, and maybe you have 3, 4, sometimes 5 axles that will complete a rotation, and this spins towards the surface of the concrete, and you dial that those spinning arms down towards the surface of the concrete, and it physically is ripping the surface of the concrete. The problem with scarification is it can create microcracking in the concrete. So while it is a mechanical method, present day not quite used as much. Shot blasting and grinding are the 2 common methods of mechanically preparing concrete. Sometimes mechanical prep, uncovers hidden problems, which causes additional prep. Okay, in renovation, you don't know what you're dealing with in a lot of cases, and sometimes you have to evaluate the floor. If there's any type of duct work coming up through the floor, remove the grill, look at the cross section. Sometimes you may have to take some core samples just to kind of see a cross section of what we're dealing with here in order to bid a job and recommend the right method of prep, prior to starting. Oil, grease, nothing sticks to it. Okay, you have an oil spot like we see in the picture here. Most likely in this situation, a little bit of surface prep probably removes all concrete contaminated with oil. But having said that, I mean, I've been on projects where, they've been service stations for 20 and 30 years, and you prep the concrete today and it looks great. Looks like clean concrete, but then all the oil that's penetrated the middle and the core of the slab, wicks its way back up to the surface because you've opened up the surface again. So, if you know that there's oil contamination in the slab, sometimes it may require taking a core sample and looking at the cross sections. Most definitely, it may take prepping today and then evaluating the surface tomorrow to ensure that there isn't oil that migrates right back to the surface once preparation has been done. Cracks and joints. We'll look at expansion joints, isolation joints, control joints, and then ultimately cracks. Expansion and isolation joints are joints that are designed in a concrete slab to allow concrete slabs to move independent of each other, and sometimes concrete slabs to move independent of a wall, or maybe there's a structural column that's sitting on a concrete caisson that was poured into, some 20, 30 feet into the ground, and you want to isolate that concrete slab from the concrete support caisson supporting that column. Those kind of joints are there on purpose to isolate movement, and expansion joints and isolation joints should be honored up through the patch or leveling product and the finished flooring for that matter. And I realize this doesn't get done because in a lot of cases, the owners don't want to see a joint like that honored through their floor covering. But if you don't, and that joint moves like it's supposed to, then it's going to crack the floor covering. So it's a matter of taking the lesser of two evils. Honor the joint, then it looks like it's supposed to. If you don't, and the concrete cracks, then the risk is, if the concrete moves and the flooring cracks, then you're dealing with unsightly floor covering. Here's a picture of an isolation joint. Typically a diamond like you see here, sometimes a triangle, but underneath that column is a concrete caisson that's supporting that column, and you typically got concrete poured all around. In this situation, unfortunately, they patched over it. Those isolation joints should be honored up through the patching material. Otherwise, you install flooring over it, it moves, and then you see unsightly cracking that's happening in the floor covering itself. Control joints are saw cuts. So slabs that are on grade will typically have a saw cut in there to control shrinkage of the concrete. We have extra water in concrete to allow it to be able to place, screeded, and finished. That water's got to evaporate out. We cut control joints so that we control the cracking to that joint. Okay, I'll teach you something new here if you haven't heard it before. But a joint is basically a crack in the concrete where we want it to be, and a crack is a joint in the concrete where the concrete wants it to be. When we put a control joint in there, we are controlling where that crack is going to happen. When the concrete cracks on its own, because there was no joint, there's no controlling where it's going to crack. It's going to crack wherever it wants to. So we cut these joints in here to isolate shrinkage cracking to the joint. They're very commonly patched with an underlayment and then floor covering installed. Here's a crack in the concrete, straight line, and it basically, the concrete's telling you that we should have put a joint there. It moved and it cracked. It would have cut a joint, would have had a nice straight line. Didn't do that. Unfortunately, the concrete cracked where it wanted to crack, and you see a nice jagged crack. Here's control joints in a concrete slab on grade, patch with a patching material, very commonly done. Okay. Here's a concrete substrate that's clean, but we obviously got to deal with some patching. Okay. The thing I want to make known to everybody is whether it's a crack like that's been patched in this picture, whether it's a control joint that we saw in other pictures that were patched prior to putting flooring on it, all the patch is doing in this capacity is filling that crack or joint and making it smooth enough so that you visually don't see it through the floor covering. If there's any type of movement in the future, the patch is not going to stop that. Okay, it's going to crack, the patch is going to crack, and you're going to see that through the floor covering. So if there's concern about a control joint continuing to move, if there's concern about a crack being structural or continuing to move, that's when we raise the red flag and get the structural engineer in there to evaluate and propose a prescription to repair. There's different types of two-component epoxies and urethanes that can be used in these cracks and joints to help bind the concrete together and stabilize that joint. But even with those types of products, it's never 100% guarantee. If that concrete wants to crack, it may crack an inch or two over where you just repaired. Okay, nothing's ever 100% guaranteed. Other substrates. Okay, we'll look at VCT with cutback, ceramic tile and porcelain tile, epoxy coatings, wooden subfloors, and gypsum substrates, and how to prepare all these substrates. So there are some products out there that are suitable for going over VCT. The thing we have to understand is after installation, that VCT is maintained with a floor finish, a wax, so to speak. So if they're considering using a product that's recommended over the existing VCT, one, we got to make sure all the tiles are solidly bonded. Secondly, we either got to strip or sand off the floor finish or the wax so that we get down to clean VCT. Okay. If we use a stripping agent, then we got to make sure that we thoroughly allow that to dry, thoroughly rinse, and then thoroughly allow it to dry before we proceed with the installation. In most cases, products that are allowed or recommended for installation over VCT, they may require a primer to get a chemical bond to clean VCT. Check with your manufacturer on that. If we see any loose tiles, we certainly remove loose tiles and basically follow the protocol that we detailed a little bit earlier here today with adhesive residues. Make sure it's not water soluble, scrape down to a thin, well-bonded residue, and prime as necessary. Ceramic tile, porcelain tile, quarry tile, okay? Certainly make sure the tile is solidly bonded. Any wax or dressings that were applied after it was installed would certainly need to be removed, either mechanically or stripped off the floor. And then follow manufacturer's instructions with the appropriate primer if necessary. Some products may require a primer, others may not require a primer. Okay, but that's an installation that's been done for years and years. Very common. Epoxy coatings. Okay, it's common that patching and leveling products with the appropriate primer stick well to epoxy coatings. Urethanes, on the other hand, are very difficult to bond to. So number one, we got to make sure that we are positive it's an epoxy coating, doesn't have some sort of urethane top coat, isn't some sort of polyaspartic, or any other type of material. There's methyl methacrylates out there. Let's make sure it's a true epoxy. Okay, let's make sure that the epoxy is sound, solid, and well bonded. Once the surface is clean, using the appropriate primer as necessary. Certainly test areas, as we said all day, should be done. Again, manufacturers aren't back in the lab testing all their products to see how well they bond to coatings. Terrazzo, okay, could be epoxy terrazzo, could be cementitious terrazzo. In either case, the material is polished and the surface ends up being virtually non-absorptive. In addition to it being polished and non-absorptive, in a lot of cases, there could be a sealer, could be a dressing, could be a floor finish. We got to get down to clean terrazzo, okay? If it's epoxy terrazzo and we strip any waxes or dressings off, mechanically remove those, get down to clean terrazzo. In most cases, you got to use the appropriate primer to get a chemical bond to that epoxy. Okay, if it's concrete terrazzo and you hypothetically shot blasted it, I mean, you may be down to porous concrete. You've blasted it to open up the polished surface. And in that case, it may require a different primer that's able to soak in and grab onto the pores, being that that's concrete terrazzo. Certainly bring your manufacturers in to help with those types of recommendations and discussions. Wood. Could be a plywood subfloor, could be oriented strand board. And I said that and just didn't say OSB because I wish I had $5 that every time somebody told me that they had a oriental strand board as a substrate. It's oriented. So whether it's OSB, whether it's plywood, number one, we want to make sure that it's sound and solid and installed in accordance to building code. So it may, for example, it may be joists that are 16 inches on center, 3/4 OSB, 3/4 plywood, fastened securely to the joints or to the joists, tongue and groove with joints staggered. Okay, that's the key thing. No matter what the code is, make sure that we have a subfloor and then the proper plywood or OSB that's all installed to code. If there is any contamination, certainly sand to clean wood. And then we follow manufacturer's instructions with regard to priming and the use of leveling material. Keeping in mind, there are some leveling materials that do not require a primer when installed over wood. So make sure you got the right recommendation from the manufacturer. Gypsum. We've certainly seen distressed gypsum in renovations. lower income housing, some of the precast hotel type work out there. You'll see a poor gypsum subfloor over top of a wooden subfloor, typically an inch, minimum three-quarters of an inch up to an inch and a half. And you get into these renovations and you tear it up, and sometimes we really don't see good results here, and it could be all despondent and loose and dust. If that's the case, shovel it all out and start over. But I mean, there might be some integrity there. It might be solid, and there are products out there present day that can be used to go over traditional distressed gypsum. Okay, the older style products, when they cured, they created a lot of tension. If they were installed over top of gypsum like this that doesn't have super good integrity, those products could cure and tear the gypsum apart. And that's the expensive way of tearing the gypsum out. But present day, there's engineered leveling products, gypsum, plaster, Portland blend products that don't create tension and are suitable for these applications. Make sure that the gyp is sound and solid. We don't have like a super weak surface, just dusty or chalky. Got to have some degree of integrity to begin with. And typically they call for a double prime so that we soak in and consolidate the gypsum, but also create an isolation material here so that the new product going down does not have an adverse reaction with the gypsum. If you have Portland cement and gypsum cement, they can sometimes adversely chemically react with each other, and it creates a material in a process called ettringite. And doing a double prime on a gypsum consolidates the surface of the gyp and seals it, but it also provides like an isolation membrane there so that the new leveling product doesn't adversely react with the existing gypsum if there's cement, Portland cement in that leveling material. But follow manufacturers' recommendations and guidelines there. The bottom line here with what we've learned today, and the critical piece here is proper prep is not a one-size-fits-all. It's determining the proper preparation needed on any given project, no matter what that may be. In some cases, it could be just sweeping and vacuuming the floor, okay? In other cases, it may require aggressive prep like shot blasting or grinding, followed by the appropriate vacuuming, okay? The other thing I want to make known to you is, rely on your manufacturers. Reach out to them, have their reps come out on site, review the installation with you, have their technical departments write recommendation letters to copy all parties involved, saying we need to do A, B, C, D, E, F, G, so that everybody involved knows what needs to be done, and things are followed in accordance with manufacturers' recommendations. All warranties are in place, and most importantly, you never have issues going forward. Okay? Take the time to do it right. We appreciate you taking some time here in our proper prep AIA seminar.
Awesome. So if you want to switch to, yep, there you go. Just a reminder that certificates for today's webinar will be distributed by email early next week. If you did provide an AIA number at registration, we will be reporting these credits on your behalf. I will also be sharing, I've been doing this for the last few weeks with our webinars, a YouTube video link to today's content. So if you have any colleagues that couldn't make it today, or you just want to review the information that Seth went over, keep a lookout for that in your emails. It will likely be early next week sometime. So we actually only have one question. So is the absorbency testing of concrete subjective or objective?
Well, number one, with regard to absorbency of concrete, it can be subjective because it's who's interpreting those results. But the object here is to determine the absorbency, whether there is none, is some, whatever the case may be. So the critical piece here is to get with your manufacturer, and in conducting that absorbency test, you're on the same page with the manufacturer so that the right recommendation is provided for that job. If the manufacturer can't get on site, you can certainly with your phones do the absorbency test, video that, FaceTime, whatever, to help the manufacturer see what you're actually seeing on site. And quite simply, it's a matter of doing like a dime-sized drop of water on the concrete for some 60 seconds, and kind of evaluating how it did soak in, didn't soak in, do we have a puddle left on the surface, did the water totally absorb in, and kind of noting what you're seeing visually. So there certainly is some objectivity here, but there's also some, it certainly can be subjective with the interpretation of the results. That's why get your manufacturers with you.
Great. We actually had a few more questions come in. So can you use self-leveling underlayment over these adhesive residues instead of grinding? And the same question for over existing floor like VCT or terrazzo, without having to remove any waxes or anything else, can you just self-level over that?
Right. So it was adhesives and then VCT and terrazzo, right?
Yeah, adhesives and then without removing any waxes. So basically like a low prep option, I think is what's being described.
Right. The risk here is they used commonly on VCT and commonly on like a terrazzo type floor. There's like a low solids acrylic floor finish that's used. It's mopped on, put down very thin. There's 3-4 coats, and that type of floor finish is typically not suitable for patch and leveling products. It was designed so that you can easily mop it on, and with a special, in some cases ammoniated, in some cases non-ammoniating stripping agent, it's easily broken down and removed from the surface. So that can be a bond breaker with the different primers that get used with patching leveling materials, and even with some leveling materials that don't require a primer, potentially that could be a bond breaker, because they're products that are designed just from a cleaning and maintenance standpoint. They don't have really good integrity. If you ever go into a Target or a Walmart or a school that has had these floor finishes applied, look for a brown or black scuff mark on there, and then walk up to that scuff mark. 9 times out of 10, you can take your shoe and rub it across that black scuff mark, and you'll see it disappear, because you're kind of easily removing a little bit of that floor finish. It's hard for things to stick to that floor finish, and for those reasons, those should be stripped off and get down to solid VCT, get down to clean VCT and clean terrazzo if that's the case. Hopefully that helped.
Yeah, and then one more question before we dig into the ARDEX products that kind of corroborate to what we talked about today. In general, what is the industry standard before product can be installed on new concrete?
Yeah, good question. So you can look at this from a variety of different standpoints. You can look at this from just the concrete itself and what's going to happen to the concrete. So when we look at just the concrete and what happens after pouring, we have typically 28 days for the concrete to develop its strength properties that are designed by specification. That's kind of like an industry number. During that time period, there's going to be loss of water due to evaporation. The concrete's going to shrink, it's going to crack. So it's always a good practice, if you're just looking to patch or level over concrete, whether it's interior, exterior, underlayment, topping, it's always good to let the concrete go 28 days from that standpoint. Let it do its thing from a strength development, let it do its thing from a cracking standpoint. But having said that, the other component here is moisture. Depending on what's going on top of the concrete, if it's a moisture sensitive flooring, if it's a moisture sensitive coating, and we have to patch or level in those situations, we may have to look at moisture. Now, which means we may have to let the concrete go a lot longer than 28 days before we put patching or leveling products on a floor covering, short of using a moisture mitigation system. Which leads me to another avenue here. If we're really pressed for time, there's products and systems out there that could allow for just a couple of days of concrete curing, and then a moisture mitigation system installed after 3 days of curing on fresh concrete, where you do moisture mitigation and patching leveling. So there's a variety of different options out there. If you have something specific in mind, we'd be certainly more than happy to talk through your specific application there and see what makes the most sense for your project, whether we just wait 28 days, go longer, moisture mitigate, or even do something in as little as 3 days for that matter.
Great. Well, I think that's all the questions that we have time for. If you asked a question and we did not get to it, we will reach out to you via email with an answer to your question. So Seth, if you want to go into some of the products that ARDEX carries now that we are finished with the AIA portion of today's webinar, go ahead.
Thank you, Alyssa. Still stuck on this slide, Alyssa. I don't know if you still had control or not.
I do not.
Okay, now I'm good.
There we go.
Sorry about that. We're going to spend a little time going over the different products that we have that cater to the patch and leveling applications. So we'll start with the self-leveling category. This is looking at our complete lineup here. K15 self-leveling that we brought to the States back in the late 70s. It's been around, was developed back in 1976. It's been one of the most widely used and specified materials throughout the years. We have a newer technology called K13. We'll spend a little time on that. We have a reactivatable product called K10, a pretty cool material. Sorry, this is advancing on its own now. The K10 is a reactivatable product, meaning you got about 20-25 minutes of working time with that product as you're spike rolling it. Then you can actually reactivate it with the spike roller to give you more working time. We'll spend some time on V1200 as well. That's our workhorse. We got a couple of specialty products here. K60, we'll touch on that. And the last one, we saw the gypsum substrates. It is K22F. We use this as a product to repair distressed gypsum. It's a hybrid material that is made up of Portland, plaster, and gypsum. Very high strength, nearly 6,000 compressive strength. Put microfibers in there that have increased flexibility. It's like 3 times as flexible as standard concrete, so pretty cool material there. K13 is a product that's gaining a lot of popularity. For us, it's our first dual water ratio. It has a standard water ratio mix, but then it has a high flow water ratio mix too. Gives the contractor the luxury of going deeper where they want a little bit more body and a thicker material, heavier body product using the lower water ratio. But if we're going in a thin application, maybe an 1/8 inch over a mitigation system, we can go to the high water ratio and do an 1/8 inch across that floor just to have a blotter layer for the floor coverings. You have that porous 1/8 inch blotter layer, so your waterborne adhesives have somewhere for the moisture to go. So that's a newer product for us, gaining a lot of popularity due to its dual water ratio. Floor covering the following day, so it's a pretty quick product from a drying standpoint. V1200 is our workhorse. This is our primary self-leveling product that's used day in, day out. It's a very cost-effective type material. In addition to its versatility, you can use it over concrete, over non-porous surfaces like ceramic or terrazzo, quarry tile, go over epoxy coatings, and even the adhesives as we discussed. So pretty versatile product there. Very good flow and heal properties with the V1200. Most floor coverings in 24 hours when you're going 1/4 inch, 3/8 of an inch. We can go up to virtually any thickness with this product. Just when you're going deeper, it takes a little longer to dry. So pretty versatile material. K60 is a pretty unique product. It does not fear getting wet. This product could be used under a moisture mitigation system and can be indefinitely damp with liquid water and have no adverse effect. It's a technology that comes out of ARDEX UK, and its original technology dates back to the 70s. It's certainly been improved along the way, and we made this a part of our line some 8 to 10 years ago. It's unique in the regard that we're not mixing it with water. We have a gallon of liquid latex that gets added to a 35-pound bag of powder. There's a lot of powdered goodies in there, and we have the liquid latex. So with the powdered polymers in that bagged product and the liquid polymer in the jug, that enables this product to stick to a variety of different surfaces without a primer. Porcelain tile, which has an absorbency of less than 0.5%. If that surface is clean, the K60 is sticking to the porcelain without any primer. Okay, it can be placed at an 1/8 inch thick, so it's suitable for that blotter layer that I was just talking about there. If you just need an 1/8 inch cementitious layer, and it certainly can be used underneath the mitigation systems. One of the key things for us is we will use it as a part of our moisture mitigation family of products, especially the MC Rapid. It's an epoxy. 100% solids epoxy. The K60 will adhere to that MC Rapid without a primer. So it really speeds up the installation of treating a floor for moisture and then leveling over top of it. One of the new products that is new to the line here is called K40. This is a self-drying technology product. We're pretty pleased with this product. Floor covering as little as 2 hours. This material cures chemically. It will has the ability to chemically bind up all the mixed water, so it doesn't have to evaporate water. So traditional floor covering like vinyl tile, plank, vinyl sheet, rubber flooring, as soon as it's hard, a couple of hours. Compressive strength on this is crazy. You're up into you're over 8,000 after a month. But the cool thing about it is, with this rapid strength development and this ultimate the strength that this product has, my thought was it was going to have a lot of tension, a lot of pull as it's curing. And this product does not have a lot of tension at all. So it's a newer technology, lower tension product, but it's self-drying and you're putting flooring on it very quick. It's also a high flow product, so we can use it at an 1/8 inch thick as that blotter layer, I was talking to you about a few minutes ago. So both the K10, the K40, the K60, all can be applied at an 1/8 inch thick, over mitigation systems for that blotter layer application. Moving on to the patching category, we have a variety of different patching materials, from interior products to exterior products to underlayments to toppings. We have something that will, for every solution out there. There's a couple here that we'll touch base on. Our Pride product is feather finish. This was a product that was born out of feedback from installers and manufacturers. This goes back to 1992 when we were in the development here, and it's a voice of the customer product. The contractors, the flooring manufacturers were fighting gypsum patches back in the late 80s and early 90s, and the Portland cement patches at that time were sanded and took a long time to dry. And many of these manufacturers and contractors were saying, "Hey, ARDEX, why can't you make a cement patch that dries like the gypsum products very quick, is unsanded like the gypsum products, but it is a Portland cement and calcium aluminum cement based product that is not affected by moisture like the gyp products are?" And we basically took that to heart and developed feather finish. unsanded, mixes with water, sticks to virtually anything, self-drying. At a skim coat, I mean, it's done in like 15 minutes. 1/8 inch, 1/4 inch, you're hard enough for flooring in about 30 minutes to an hour. It's been the patch for a lot of years. Dating back to 93 is when we officially introduced that project. We also, back in the mid 90s, introduced a product called SDP. It's kind of called a feather finish and SDP, like the 1-2 punch. SDP is a sanded material, has sand in it, and it's designed for ramping and screeding and floating applications, 1 inch thick, 2 inches, 3 inches thick. So you can make transitions with this, create ramps with this material, but it's self-drying, so it's like a rock in about an hour. You can put floor covering in it in as little as 60 to 90 minutes. So SDP is your rampable, slopable, screedable type transitioning repair mortar. Feather finish is your unsanded skim coat product. Both products are self-drying and allow flooring on it in as little as 60 to 90 minutes. Newer product for us, and this is also a voice of the customer, as we see more and more floor coverings being suitable to 100% RH. The problem with these adhesives and floor coverings is your traditional patching and leveling products, pick a manufacturer, they can't handle liquid water or being damped indefinitely. We answered that from a leveling standpoint with K60, but from a skim coat standpoint, we didn't have a product that fit that mold. We wanted, the field wanted an unsanded, water mix only product like feather finish, but could be indefinitely damp, could be used outside if necessary, without being broken down by constant, liquid water. We developed MRF, that stands for moisture resistant finish. Can be used outside, it's weatherproof. It could be indefinitely damp with that no adverse effect. We can use it, just like K60, underneath the moisture mitigation systems. It doesn't matter if this stays wet indefinitely. Okay, that's what it was designed for. So now the 1-2 punch with regard to moisture and 100% liquid water, RH, you got K60 for the leveling standpoint, you got MRF for the patching and skim coating standpoint. So those two go together. With regard to our systems, we certainly talked about substrate preparation here, but we have a complete line of moisture control products I've touched a little bit on here. Back in 2000, we acquired the W.W. Henry Company, the world's largest and oldest adhesive manufacturer. We acquired them from Armstrong. So W.W. Henry's been a part of ARDEX for 20 years now. We have the Henry brand of adhesives under our umbrella. We have a full line of exterior grade engineered repair products as well as structural repair products. When you look at ARDEX from a global standpoint, even though ARDEX Americas was always known as the patching and leveling company, when you look at us from a global standpoint and the ARDEX, the 44 ARDEX companies, globally, technically we're a tile and stone installation products manufacturer. In the other parts of the world, Europe and the UK and Australia, et cetera, the core business ends up being tile and stone products. So needless to say, we have a complete line of waterproof membranes, thin set mortars, specialty mortars, grouts, uncoupling membranes, heat systems, full line of tile and stone installations. And then finally, we have a complete category of finished surfaces. Dating back to the mid 80s, when installers wanted to use our self-leveling underlayments and our patches as toppings, we decided to develop products specifically for that. So we've been doing finished surfaces back into the 80s. The decorative aspect, the integral color, topical stains, decorative saw cuts, logos dates back to the 80s as well. And as a manufacturer, we strongly got involved with these to support our customers into the 90s. So we've been doing the integrally colored applications, the decorative saw cuts, the logos, for many years. Polishable toppings, we've been doing that for 10 years now. And our global brand of decorative materials is called Pandomo. And Pandomo is basically decorative floor, wall, ceiling. You know, whether it's trowelable, whether it's self-leveling, there's many options of integral color, topical stains, decorative saw cuts, logos, polish, you know, etc. So I just wanted to let everybody know that in addition to us being known as the substrate prep manufacturer, you know, we have moisture control, we have adhesives, we have engineered and structural repair products, complete line of tile and stone, and a complete line of decorative finished surface products. So I want to personally thank you and thank everybody for, you know, spending a little time with us this afternoon here. If any questions come up, you know, after we're done here, don't hesitate to reach out to us. And Alyssa and I also wanted to let you know, I know she mentioned in the beginning, but we'll let you know here again some of the upcoming AIAs in weeks to come. So as she said earlier, we had great reviews on the polished concrete, so we're doing that one again on the 14th. We have a tile and stone systems AIA on the 21st. We have a guest speaker, you know, coming in. Still working through that, but if all things go as we have planned here, it's going to be a pretty cool one. So stay tuned on that one. And then I'm going to be wrapping it up on June 4th. I did on adhesives and navigating high RH AIA a few weeks back. We're going to be doing that one again. If you didn't catch that one, this is brand new, and we focus on the high RH adhesives and high RH floor coverings and what you need to know to include, you know, what patching materials to look for, you know, as I mentioned a little bit ago. So again, from my standpoint, thank you very much for the time here. If we can help you out any way, please let us know.
Yeah, thank you so much for joining us. Have a great day.